Welcome to Insight Builder channel, large language model automators, Python experts, and my dear friends. Loading GPTQ 4-bit model with Exllama. How to load a 7 billion parameter model in less than 4 GB of GPU VRAM. That is going to be our discussion in this video. Okay, so before we go into this discussion, if you have been following up with my earlier videos, then you would have come across this discussion on model backend GPTQ 4-bit quantization. If you have followed this video, you would have seen that there are various types of various methods of loading the models, and this particular video that you are seeing here would have already given you the necessary background. So if not, then take a look at this video. It will actually help you to understand what is going to come next more easily. Let us go to the PDF. The point I wanted to make here is there are various ways to reduce the size of the models. Among them, the chief method is called as quantization, and there are various algorithms available in the ecosystem, open source ecosystem currently, and among them GPTQ, that is general pre-trained quantization, meaning after the model has been pre-trained, the model is quantized to a lesser size of the parameters. So regularly the parameters are either at 32 bits or at 16 bits. So that is how the parameter sizes are. Okay, so you might be completely new to large language models, the discussion on parameters. You might be not even aware of what is a neural network. So if that is the case, then go ahead and look at my earlier videos in this particular playlist. So I explain each and every detail with respect to the models, with respect to how it is getting loaded, how it is getting quantized. Especially this particular video will go deep into the understanding of what is a model, how it is getting trained, how it is getting quantized. So from the computer science perspective, you will get a lot of information in this video. So at the end of the day, it's actually easy once you understand the basics. So that's why I insisting on watching these videos for your benefit. Let us continue with the discussion. So we are trying to load a model, the actual neural network model, that is 28 GB in size, that is actually reduced to a size less than 4 GB. When I convert the 32-bit parameters to a 4-bit parameter using the GPTQ algorithm that has been written by the various teams, open source teams, so the model size reduces to 4 GB. After the model is reduced to 4 GB, the inference can happen in a single T4 GPU that is provided for free in Google Colab. You'll be seeing that in the demo in a couple of minutes. You can build chatbots with Gradio. So if you guys are, if you want to actually build a chatbot around it, you can take a look at these 3 videos that I recently uploaded. And you can use that use the idea that I share in this video along with that video also. You can connect the model to use for vector query searching with larger context, because it can be easier to analyze the document and less time is spent on waiting. So all these are benefits that you get by using GPTQ 4-bit quantized models. And not all the models are compatible with this 4-bit quantization. So there's a lot of research and a lot of programmers are working round the clock in the backend to make more models to be 4-bit quantized, and they share it to the open source community, and they share it in Hugging Face Hub. So I believe that you have already got the Hugging Face Hub account. If not, do get an account in Hugging Face Hub, sign up for it, and then you will be able to work with those models. It's not that you need the account, you need to sign up in Hugging Face Hub. Without that also you can download the models. However, it is better that you sign up and you start understanding what is there in Hugging Face Hub in more detail. Okay, so I have shown you the benefits. So what are the steps to load? So after this explanation, I will go to the demonstration. First and foremost, you need to download the config files from the Exllama repo. So this is straightforward. We are going to use the classes that has been written by the Exllama developer, and we are going to load the model using those classes only. In order to load the model, you need to get the model weights, correct? So the 4-bit weights of LoRa model is already uploaded into Hugging Face Hub. We will be downloading that, and we'll be using the existing LoRa configuration. So LoRa means low ranking adapter. So it is basically a configuration file that wraps around the models. So that particular configuration file, we'll be getting it from Stanford Alpaca repository. That also the links etc. will be provided. You don't need to search for it. We need to send the config and the models through Exllama classes that we downloaded from Exllama repository, and then you start generating. So all these things will be now discussed in detail. So let us go to the browser again. The code that I'll be working on is already shared. So this particular code that I have placed in the Jupyter notebook was actually taken from this Exllama repo, TurboDerp Exllama repo, and where he explains in example_LoRa how to load the model. So you guys might have a good system which has a GPU, and you can actually run this entire script in a single go. So it will work for you without any questions, any issues. Yeah, you might have to change this locations, but apart from that, rest of the things will work. But even then, it is better that you understand what is going on using this Google Colab Notebook first, and then later you can actually move to running the script directly. Okay, so let me close that, and we will be using the Alpaca LoRa repository. So this is the Alpaca LoRa repository. I'll be sharing this link also with you guys in this description of the video, and also I'll be sharing. So this is already shared in the earlier discussion, so you can get it from there. Without further ado, let me start discussing this particular Jupyter notebook. So this notebook is already enabled with GPU, and you see the GPU is at 5.8 GB. So why is it 5.8 GB? Because this particular notebook is already executed, meaning I have already loaded the model into the GPU. So I'll be just going through these steps, and you can actually execute the same Jupyter notebook and you will be getting the same kind of an output. So nothing different here. We start by installing all this necessary libraries, and you see there are a couple of new libraries. One is Ninja, and another is Safe Tensors, another is Sentence Piece. So these libraries are required by Exllama, so do download that. And there is also this CU118, that is CUDA 118 PyTorch library is also required, so do install that. Okay, so if you have already got all these things in your laptop or in your server, then you don't need to do that. But if not, then you have to do it. Again, after you do these things, then you clone the Exllama directory. Okay, so here it's a little bit different. Okay, what happens is Exllama has a couple of files in his own directory. Among them, the chief is wait a minute, let me go into Exllama. Yeah, I am in Exllama. So among them, the chief is the model, the LoRa library, the LoRa file, the model file, and the tokenizer file. So you see these files, right? So these files are used by the rest of the cells in the Jupyter notebook. So in order to ensure that rest of the cells are executed based on inside this Exllama folder, what we are doing is we are using this %cd command. So this will ensure that all the rest of the commands or the rest of the cells will execute inside this Exllama library, Exllama folder. Okay, keep that in mind. So this is a new change that has been done. So you see the present working directory is Exllama. Okay. Now, once you do the import, after you do the cd only, this import will work. If you don't do this change directory, then this import will fail, because by default Google Colab Notebook will have the present working directory in the content folder, that is this folder. It will not be inside Exllama. So this is something that I realized after trying this particular notebook. So I have to install transformers also. And this is where I am getting the alpaca LoRa repository. So I'm just doing a git clone, and then I am getting the 7-bit model llama. So this particular model, 7-bit model, has been provided by Neko Institute of Science. So this is another one institute which is also working on converting the parameters to 4-bit. So the llama 7 billion was created by alpaca team, Stanford team, but that Neko team has taken that model and then they have converted that model to 4-bit version. So this is what Neko team has done, and we are going to use this model only. So you might be questioning, then why are we downloading this? Let us continue further. I will explain to you. If you have seen the code that Exllama has provided, so there is 2 directories. There is model directory and there is LoRa directory. So now you know the model directory. So the model directory is wherever this particular file, this particular model gets downloaded. So that is llama 7 billion. So that will be inside. So since I have done already the CD here, all the download happens inside the Exllama folder. Okay, so you see the model is inside this folder, and alpaca model is in this folder. Okay, continuing further. The reason why I'm going through all this in detail is that there are possibilities of errors coming up if you don't follow the exact process. You might be using your own system, and if you miss any of the points, then it will actually error out in your system. So understand why I am doing certain things so that it will be easy for you. Next is what now we are going to load the model. Okay, so to load the model, the tokenizer path is going to be in the model directory. So the tokenizer by default is going to be in the model, so you don't need to worry about it. You need to use the tokenizer that is inside the llama 7 billion 4-bit. Do not use the one in alpaca. Do not use this. Okay, next, in order to load the config, also the regular config. So this is a configuration that you get with llama 7 billion, that is in model config path. So that is part of the model directory again. And then we have the model directory for safe tensors, that is also there, and we have the model path. So all of these things will refer to this particular directory. Continuing further, when it comes to LoRa configuration, that is when we will be using the LoRa directory. So we will be only using the configuration, adapter configuration file from LoRa directory, and we will also use the adapter model later in the discussion. So we will see how it works out. Okay, as of now, initially we will use only the adapter configuration. Okay, you will see why we are using it. So we are going to take adapter configuration from LoRa, and we are going to send first of all we have to know where is the adapter configuration is. Initially what we are going to do is we are going to send the actual 4-bit configuration, that is this configuration file, into Exllama config. Okay, so this is the first thing that we do. Next, what we do is we actually take that config and we create the model out of it, and we create the tokenizer out of it. So these 4 commands are going to create a GPTQ version of the model. So the config is the actual config path from the Neko Institute model, and then the tokenizer is also from the Neko Institute model. Got it? Next, we are going to catch the model and we are going to generate it. So all the steps will lead you to a large language model generator. So if you use this particular Exllama generator, we'll be using it in a couple of minutes, and you can start chatting with this generator. Okay, now this is one step. So this is all one step. The second step is where you are trying to load the LoRa model. So in order to load the LoRa model directly, we can actually take something called as Exllama LoRa. So like how you have Exllama config here. So this is for the 4-bit model, and this is for the Exllama LoRa model directly. This is actually the basic LoRa model that is available, and that also you can load it, and then we can actually change the configuration. You might be now wondering, Kamal, here I have a confusion that this model refers to Exllama config. So how is this actually working out? Okay, so what is happening is there are two ways of configuring the file, and Exllama developer had shown us both the ways in this in his discussion. Okay, it's not that you have to do this particular step. You can actually skip this and you will still be able to get the config. You will be able to still get the large language model. You actually don't need this. This is only there for to compare, right? So keep this in mind, because if you are going to go through the entire notebook, then you need to understand what is going on. Continuing further, so all these are basic setups that we need to do for any large language model to work: the temperature, the top P, top K, and the repetition penalty, etc. So all these are done. Okay, now comes the interesting part. So what we are doing is, this is a basic test Exllama developer does, TurboDerp. So he is telling that, okay, to the model that below is an instruction that describes a task, write the response appropriately. And then we are going to use the generator with LoRa. Okay, this is with LoRa, and then you see the output. So you are going to use the generator. The generator is here. So we have triggered the generator here, and we are going to say generator.generated simple, and we are going to send the prompt that we created here, and then we are getting the output. So you see the list of the 5 colors in alphabetical order is brown, green, orange, purple, and red. So it is able to follow these simple. Let me zoom in a bit so that you guys can see it better. And this particular setup, this particular model is able to follow the basic instructions. Now, the next step what was done is that a bigger, larger context is provided to the model. So here is a large context, and this is almost some 4,100 tokens, if I am not wrong. And here, after all this context has been provided, the question is asked: how are LLMs pre-trained? So this is a question that I'm asking, and I'm sending it through LoRa. So here is the generation, and you see, initially I was also confused that it is actually repeating whatever I'm providing it in. Okay, but finally, once you come down, you see after this particular prompt, LLMs can be trained either autoregressively using BERT or autoregressive model, and then it actually provides the answer. So here, you see, given a sentence like "I like ice cream," the model might choose between like and don't like. So here, this model is actually answering from the context. So this is the aspect that I was trying to tell when I was discussing this benefits. So now you can actually work with if you're going to use vector query application, then you can have a larger context length, and you can use it for document analysis also. So let us go back. Okay, and okay, I have not tried this, so I am going to try how well it does if I ask some other question. So let me ask how many words are there in above essay. Okay, and let us see whether the model is able to give us the answer. Okay, and let us see the output. So basically, this is something that I am trying right in front of you, and let's see how the output is coming out. Okay, so as you can immediately see, how many words are there in the above essay? Answer the following question: what is the length of the longest sentence in the given essay? So no, the answer that we expected out of this model and what we got is completely different. So you might be wondering, Kamal, it's not working out the way we want. So okay, keep one thing in mind. There are certain tasks that these models are trained upon, and there are certain tasks these models are not trained upon. So the questions that you ask, the task that you wanted to do, you need to actually go back and check the model instruction tuning processes, and then decide, okay, whether this model is useful for my kind of questions. So if the model is not working out, then most probably it is not trained for it. Keep that in mind whenever you're asking such questions, and if it doesn't work, it is because of that. So you need to understand that aspect of training, fine-tuning of the models also. I have a separate discussion where I talk about parameter efficient fine-tuning, where you can fine-tune large language models with the data that you want, and then you can use the fine-tuned model for your purpose. So that is one of the options that you can think of. Okay, but the point here is the model is able to infer it. It is giving a wrong answer, but it is still giving an answer, and it is doing it at really high speed. And moreover, it is actually using a very less amount of RAM, that to GPU RAM. So this is one more thing that I've tried, that one more prompt that I've tried. And in this case, what was the estimate of 2020 study? So this is a blind question that I'm asking to the model. So basically I'm asking this particular line. So LLMs are computationally expensive to train, and a 2020 study estimated the cost of training a 1.5 billion parameter model, 2 orders of the magnitude or smaller, okay, is anywhere around 80,000 to 1.6 million US dollars. Now let us see whether the model is able to answer. And if you come down, so you see this is the answer that has been provided. So the answer is still wrong. Okay, the answer is not 1.6 million, it is saying 8 million. But the data that it has collected from the above is still correct. So GPT-3 training is 1.5 billion parameters. So these things are still working out. So the model needs to improve, as we already told, but it is actually doing as best as it can. And the next couple of steps actually tells you how to use the model without LoRa configuration. So this is that is something that I have done here. Okay, so now with this we have come to the end of loading the model and testing the model, working and understanding what exactly happens with the model. I believe that you have learned a thing or two from this discussion. Do take this particular Google Colab Notebook and start working out by loading the model. At the end of the day, all it takes is connecting to the GitHub repo, connecting your Colab Notebook, and start working on that. So I think it will be much more easier for you to learn by doing. And I believe that you have learned a thing or two from this discussion. So do leave a like and share it with others. Subscribe to my channel for further updates on similar kind of large language model discussions, as well as Python related open source ecosystem libraries. So with that said, I would like to leave this video with 4 words, that is practice, 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 practice. See you guys. Have a great time.